Welcome to the Cal Corporation's series of videos about software engineering. The topic of this video is Unary transform traits. Before proceeding, make sure that you have already watched these other videos first. Because this example class uses two template parameters, the client code has complete freedom. It could specialize the template such that the TT member has any type the client wants. But what if we don't want to have that much freedom? What if we only want to have specializations that follow this pattern? We want the TT member's type to be the same as the T member, unless the T member's type is a reference, in which case we want to drop the reference part of that type. In other words, we want to think of the TT member's type as a transformed version of the T member's type. And if all specializations are going to follow this pattern, then the second template parameter is redundant, and we should remove it. The nice thing is, now we're protected from accidentally specializing in some way that doesn't fit our desired pattern. But how do we get the compiler to perform that type transformation? It would need to do some processing at compile time based on an input type, the type T. Well, we've already seen something like that before. A predicate trait does processing at compile time based on an input type. Remember that a predicate trait was implemented by dummy types, which contained that trait information in the form of a nested Boolean value. What we need now is a transform trait. A transform trait's nested information is a type alias. By convention, this nested type alias is always given the name of type, lowercase type. Instead of writing your own dummy class for this purpose, C++11 provides a standard one for you. Of course, it uses templates instead of creating a new dummy class for each possible type. Again, C++14 added an unimportant cosmetic tweak to these traits. We prefer to still use the original form because the original is more clear that we're actually using a nested type alias called type. Now that we understand what a transform trait is, we can use one to solve our original problem. There are many built-in transform traits for doing things like changing the sign of a type, adding or removing indirection by a pointer, adding indirection by a reference, adding constancy, and several others.